Hello everyone, welcome back to the channel. Today we are starting with second topic in number system, that is remainders. Understanding remainders is very important to solve the question on remainder topic, as well as it is going to help you in another topic of number system, that is divisibility rules. Let's start and let's see how many questions were there from this topic. If you see in 2020, this is 2020. If you see, we had two questions in 2020 and there were none in 2019. But divisibility rule and remainders are mostly complementary, and so understanding one is automatically going to help you in other topic, right? So let's start and understand what exactly is remainders. Okay, so if you see, these are the question number 54 and 56. We are going to solve these question in the end. So starting with what exactly is a remainder. Okay, so in simple terms, if you divide a number with another number, right? If you divide a number with another number and you are left with nothing, means if it get completely divisible, then we say remainder, there is no remainder. But if the number is not divisible by that number, then we say there will be some remainder that will be left in the end, right? So just for your ease, let's start with a simple example. Suppose number is 15 is getting divided by say 4, right? 15 is getting divided by 4. So how will you understand this? So you will recall the table of 4 and you will see that 4 3s are 12, right? 4 3s are 12. So what are we left with? We are left with the remainder of 3. Not the remainder, just we are left with 3. This means 4 multiplied by 3 is 12, plus if we add another 3, that is, then you will get the original number 15. You understand? So if now let's take another example of, suppose the number is 12 divided by 4. So now recall the table of 4. 4 3s are 12, and what are we left with? We are left with nothing. Means it is completely divisible by 4. So 12 is completely divisible by 4. Remainder is 0. Now suppose I take another example and 13. Now divide 13 by 4. So 4 3s are 12. What are we left with? 1. So we'll say this part is remainder, right? This part is remainder. This is divisor and this is quotient. Just remember these three terms. This is quotient, this is remainder, and this is divisor. And the number which is getting divided, that is 13, is known as dividend. So let's say that is a number for the ease. So we have to know three terms. Divisor, that is what our original number is getting divided by, right? Quotient means what is the closest multiple of our divisor, till which we can go. This means if 4 and 15 is there, the closest we can go is 12, right? And to get 12, we need 4 into 3. So this 3 is divisor. And after that, if we are left with some remainder, that remainder is this part, right? So I will just remove this part, and now we'll understand what exactly the quotient, remainder, and this, right? So first example we started, I told you that 15, what we did, 15 I wrote here 4 3s are 12, we are left with remainder of 3, right? So this means number is 15. What is divisor? Divisor is 4. What is quotient? Quotient is this part, 3, plus remainder is 3. You get it? Now if I ask you what is 11, how can we write in this form 11 divided by 4? You will write 11 here. 4 2s are 8, we are left with 3. So we'll say 11 is 4 divisor, 2 quotient, plus remainder of 3. And if it is 12, so we'll write 4 into 3 plus 0. Since it is completely divisible, so we can say that if remainder is 0, that means 12 is completely divisible by 4. I hope you get it. This is what a remainder is. Just a basic definition what exactly a remainder, right? Now let's move to a little more complicated questions, means a more complicated part. If we see here, okay, now here before doing this part, let's come to this part. What exactly is remainder theorem, right? Now we know 11, when 11 gets divided by 4, it gives us a remainder of 3. When we divided 15 by 4, we are dividing all of these by 4, right? When we divided 15, we got 3. When we get divided, suppose 13, we got a remainder of 1, right? Now we know individual remainders. Now if someone asks you what is 11 plus 15 plus 13 divided by 4, what will be the remainder? One thing you can do is you do 11 plus 15, 15 plus 13, and that is going to give you a number, and then divide that number by 4 and you will get a remainder. Long process. The easier process will be if these are given, if the number are given in the form of addition. What is remainder of 4 divided by 11 divided by 4? 3. I will use another pencil, so just to differentiate. What is remainder of 11 when divided by 4? That was 3. What was remainder of 15 divided by 4? That is 3. What is remainder of 13 divided by 4? That is 1. So you get 3 plus 3 plus 1, that is 7. You are left with 7. Now can we divide with 7 with 4? Yes. Now do the divisibility here. So if you divide 7 by 4, you will get final remainder as 3. This is another way in which you can use the remainder theorem, right? So if you read here, if an original number is sum of 3 different numbers, if a number is sum of 3 numbers, then the remainder of that number by our divisor, suppose we say this number gets divided by 4. So what are you going to do? You take remainder of this divided by 4, you take remainder of n2 divided by 4, and you take remainder of n3 divided by 4, then you add all of them and you get the final result, and that is your remainder. I hope this part is clear. Now similarly, if someone ask you what is the remainder when 11, 15 and 13 multiplied, and whatever you get in the final result, divide that by 4 and now tell me what is the remainder. It is very difficult process. You cannot simply do 11 plus 15 plus 13 and then divide by 4 and to get to the final answer. No, only what I am going to do, remainder of 11 by 4, that is 3. Remainder of 15 is 3. Remainder of 13 is 1. Now you have to replace the sign with the whatever has been asked in the question. You will get this answer. So what we get here, 3 into 3 is 9. Can we divide 9 by 4? Yes. So when you divide 9 by 4, you are left with a remainder of 1, and that is the required answer. I hope this is clear. Now if when we will go to the more difficult questions, the concepts will eventually get more clearer, right? Now let's see. This is going to clear your doubts regarding the remainder theorem which we have learned, right? Now the question given here is, what is the remainder when 1991, 1992 and 1993 are divided by 7? So are you going to multiply these number and whatever you get in the final result and then divide by 7? No. Cumbersome process, not required. What you are going to do, just pick this number 1991 I am going to put here, and then divide it by 7. What will I get in the answer? Suppose 1991 is going to give me in the answer 7 to 14, 59. 7 is a 56, 31. 7 4 are 28. Here I finally am getting a remainder of 3. So when I divide 1991, the remainder I am getting is 3. When you will do it for 1992, you will get a remainder of what? 4. When 1993, you will get a remainder of 5. So simple. I will tell you a simple method here. Suppose someone says you tell me remainder of these number 1993, 1994, 1995 and 1996. Do this division only for one part and you get a remainder of what? Remainder here is 3, right? Now for 1992, the remainder will be just 1991 plus 1. Did we not do it? That if you have been given two separate numbers, calculate individual remainder, मतलब कि 1991 का remainder with 7 and 1 का remainder with 7, you will be left with 3 plus 1 and the answer is 4. What will be the remainder of 1993? That will be 1991 plus 2. That is 3 plus 2 means 5. If you move ahead, that this will be 6. This will be 7. But if when we get 7, can we not divide 7 by 7? You will get final answer as 0. So the remainder is like 3, 4, 5, 6, 0. Then it will again start from 1, 2, 3, 4, 5, 6, then 0, then 1, 2, 3, 4, 5, 6. So the remainder will always go in, for 7 it will go in this form 0, 1, 2, 3, 4, 5, 6. This is just a side note how we are calculating the remainder without doing the calculation. So we got remainder as 3, 4 and 5, right? If this concept is not clear, just rewind the video. You will understand what we are trying to say here. This is 3 into 4 into 5. What we get 3 into 4 into 5? 5 for the 20 and then 3, 60. So 60. 60 divided by 7 is 50. So we got final remainder as 4. So now tell me, is 1991, 1992 and 1993 multiplication is easier or 3 into 4 into 5 easier? So obviously what you are going to do, first step, always check individual remainders, then do the multiplication or addition, then whatever you get in the final result, suppose we have got 60, divide that by your 7 and whatever you get in the final answer is the answer of the original number. So our answer in this case is number 4. I hope this is clear. And one more thing, this remainder theorem only applies in the case of addition, subtraction and multiplication. Subtraction we will do when we are going to see the negative remainder concept, but till then just remember add, subtract and multiply. Now let's move to the another part. Now before doing this, now tell me, did I not tell you if a number is completely divisible? Suppose the number we have is n. If number is completely divisible, divisor into quotient, and we are left with 0 remainder, did we not say that number is completely divisible? Right? That concept we are going to use in such a question. Suppose in exam you are given a question where you have been told, tell me what is the remainder when 15 into 22 into 21 is divided by 99. So what do we need? What exactly do we need? So I need always, if such a question in multiplication is given, try to get 99 in the multiplication if you can. Try to get 99 in the multiplication if you can. Why? We will show you. So starting with, can we not write 15 as 5 into 3? Yes. Can we not write 22 as 2 into 11? Yes. Can we not write 21 as 7 into 3? I hope this is clear what we have done. 15 is 5 into 3, 22 is 2 into 11 and 21 is 7 into 3. Right? Now do another thing. Pick this 3 this 3, this 11. And what you get on finally answer? 339. 9 into 11 is 99. So we have got 99 into 5 into 2 into 7. I hope this part is clear. 99 into 5 into 2 into 7. Now divided by 99. Again we are going to use the remainder theorem. What is the remainder when 99 is divided by 99? Obviously 99 is completely divisible by 99, so the remainder is 0. And whatever we get remainder of with 5 is 5, remainder with 2 is 2, remainder with 7 is 7. See, 5 to 7 are not significant in this case, simply 0 into 5 into 2 into 7. So finally we have got an answer of 0, right? So this means 5, 15 into 12, 22 into 21 is completely divisible by 99. I hope this is clear. What we have done, if we are given such a question, try to make it into a form of 99 into some extra number, say x. So if we are able to extract 99, that means 99 will be completely divisible by 99. So we'll get 0 into something x. So we are finally getting 0 as answer, remainder, right? So you just have to know when the number is completely divisible by the other number, the remainder we have is 0. I hope this part is clear. Now let's move to the next part. Next part is, this is another case given to you. What we have here, they've asked what is the remainder when 2 raised to power 96 divided by 96. See, the difficulty is increasing with each question. So if you find the difficulty, always rewind, go back to the video, try to understand. If you have any doubt, put it in the comments. If we have a number of comments, I will solve those doubts in a separate video if needed, right? So now see, 2 raised to power 96 divided by 96. Where looks like it's a difficult question to solve, right? So what we need here is simply, if I have already told in the last question, whenever such a question is given, try to extract 96 if you can, right? Did I not tell you 96? So I know 2 to the 4, 4 to the 8, 8 in 8, 2 to the 4, 8 into 4, 8 for the 32, 32, and we need 32, 3 to 6 into 96. So this question, let's change a question here, because what we are trying to understand here is we will not be able to get it here. So let's say instead of divisible by 64, I will tell you the 96 part in a separate question, but here let's change the question and see what is the remainder when 2 raised to power 96 is divisible by 64. 2 raised to power 96 is divisible by 64. Now tell me, in this question, can we not make it form of like 2 into 2 into 2? What do we need? 2 into 2 into 2. So what exactly is this? Is this not 8 into 8? Is this not 64? So if we are able to extract 64 and we are left with how many 2's we have taken? 6 2's we have already taken out, and we are left with 92's. I hope this is clear. We have taken 6 2's out of the equation and we are left with 92's. Just ignore this 2 raised to power 90 part. Just focus on this part. When I have extracted 64 completely, so did we not get the answer as this 0 into 2 raised to power 90, and we are getting 0. I hope this part is clear. When we have divided 64 by 64, we have got the remainder. 0 into something is 0. Right? Now, moving to the next question, next part. And this 64, 96, 2 raised to power 96 divided by 96, this I have noted. I will clear this part in the next video. Right? Now, let's move. Next, this is the case number 2, that is negative remainder. What exactly is negative remainder? See, I have already told you. Suppose, let's take it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now tell me, if all these numbers are divided by 7, what will you get? I will write 14 here as well. If I divide 1 by 7, I will get a remainder of 1. If I divide 2 by 7, 2. 3 by 7, 3. 4, 5, 6. When I divide 7 by 7, I will get 0. When I divide 8 by 7, I get 1. When I divide 9 by 7, 2. 10, 3, 4, 5, 6, 0. Can you see the pattern here? So when we are dividing by 7, you are getting a clubbing or grouping of 1, 2, 3, 4, 5, 6, 7, 0. Again it will repeat 4, 5, 6, 0, right? Now, can we not write 1, 2, 3, 4, 5, 6? Yeah. So if 13 is divided by 7, can we not write it as 7 into 1 plus 5? Is it possible? 7 plus 1, 7 into 1 plus 6. So 7 is the divisor, 1 is the quotient, and 6 is the remainder. What is the other way in which this can be written? Can we not write it as 7 into 2 minus 1? Means 7 into 2, 14, minus 1, 13. That is also possible. So this means that 6 remainder and minus 1 are the same. Right? 6 remainder and minus 1 are the same. You getting it? So this means if we have 1, 2, 3, 4, 5, 6 and 0, add 6, 7 to 6, you are getting 7 plus 6, 13. Add 7 again, 20. Add 7 again, 27. 6 minus 7 is minus 1. Minus of subtract minus 8. Minus 8 and minus 7, minus 15. So this means all of these are the same remainders for 7. Same remainders for 7. Either if someone gives you remainder is 6, then can you not say 6 plus 7 is also equivalent to 6? 13 plus 7, 20 is also equivalent to 6. 20 plus 7 is also 27 is also equivalent to 6. Also 6 minus 7, that is minus 1, is equal to 6. And again minus 1 minus 7 minus 8 is also equivalent to 6. So this means in case of divisibility by 7, all these remainders are same. Let's take another example of 3. If 3 plus 7 is done 10, they both are the same remainders. So you can say, suppose if someone tells you, I divide a number and you're getting final remainder as 3. If you divide a number by 7 and you're getting final remainder as 3, that 3 you can also write as remainder as 10 if you want. If I want, I can also say 17. If I want, 3 minus 7 is minus 4. So in case I want to say a remainder is 3, I can also say that remainder is minus 4. That remainder is 10. So if I just give you in this case 5 divided by 8, tell me what is the remainder when 5 divided by 8? You can calculate it and you will get the remainder as 7. Right? Can you not do it 7 plus 8? Or can you not do it another thing? Can you not do it 7 minus 8? If you want, I can do 7 minus 8. I have already told you that 7 is a remainder and you can add and subtract divisor from it and there will be no change. 7 minus 8 is minus 1. So this means there is a concept of negative remainder in also. Negative remainder means suppose I get a remainder of 3 when divisible by 7. You can add 7, you can subtract 7, the remainder is going to be the same. Right? Now, just to clarify your concept, this is the question given to you. Right? 7 raised to power 21 divided by 50. 7 raised to power 21. Now, for the simplification, I will write it as 7 into 7 into 7 into 7. I am just doing a grouping. Why? You will understand. 7 into 7 and so on. So this is a grouping of 2, 2, 2. This means I will have 10 such groups, 10 groups of 2 each. That will make it 20 and there will be one single 7. I hope this is clear. 10 groups of 2 each, that will be 7 into 7, and there will be one separate 7 left because we have 7 raised to power 21. Now see, when I do 7 into 7, what did I get? 49. 49. Divide 49 by 50, you are getting a remainder of 49. 49 divided by 50, you are getting a remainder of 49. As I've just told you, you can add 50, you can subtract 50, you can subtract as many multiple of 50 you can, as many times you want to subtract 50 out of it, the remainder is going to same. So this means that 49 is equal to 49 minus 50 minus 1, or 49 plus 50, 99. So you can write 7 into 7 ka remainder as 99, 49 or minus 1. Whatever you want. You can write it as minus 1, you can write it as 49, and you can write it as 99. Whatever you find, you can do it. Right? So 7 into 7 is going to give me a remainder of minus 1. Another group, minus 1. So such 10 groups are going to give me minus 1, and there is one single lone warrior. So these are 10 groups. Right? So this I am getting minus 1 raised to power 10 into 7. Minus 1 raised to power 10 gives me minus 1 into raised to power even power is 1. Multiply is 7. So you are getting final answer as 7. So 7 is the remainder in this case. Remainder is 7 in this case. I hope this is clear. I understand this is a little difficult topic to grasp in the first go, but you have to solve a lot of question in this topic to understand it better, and I can assure you this gets simpler with more practice. So there is no other way. Now, as I've already told you, this in this part 2 raised to power 96 when divided by 96 is left. We'll see this question. Apart from that, this practice question is there for you in the PDF. You can download this PDF from the channel, Telegram channel, and then try to solve this question on your own. And I will just to give you an idea what in this concept, our concept of negative remainder will be used. So that is going to help you in this question. So try this question, and apart from this, the other 2 PYQs we will solve in the next video. For then, till then, that's all for this video. That completes the theory for remainders, and we have 3 to 4 questions to be covered in the next video. Thank you and best of luck.